Sometimes we have two populations and we want to know something about the difference between the means of each of those populations. Now, if we don't actually know the means, we could take an independent random sample, one from each population, and take a look at the difference in means between the samples. And this would give us a point estimate of what the difference between the means of the population may be. Now, in order to come up with something more than a point estimate, to come up with a confidence interval for the difference in the means, then we need to think about what the distribution of the difference in means looks like. So we're going to make use of our extension of the central limit theorem that allows us to approximate this distribution as normal, assuming the two sample sizes are large enough. So we need to recall from our extension of the central limit theorem that the mean of the sampling distribution of the difference between the two means is equal to the difference of the population means for the two populations. And the standard deviation for that sampling distribution is equal to the square root of the variance of the first population divided by the sample size taken from that population, plus the population variance of the second population divided by the size of the sample taken from that distribution. Now, we also said that we can approximate this sampling distribution as normal, given that our N1 and N2 are large enough. And so we're going to have our standard normal variable z, where we're taking our point estimate minus our mean divided by our standard deviation. So what that looks like is this. So now, just like we did with a single sample, we can find a confidence interval for the difference in the means. We can claim that with a probability of 1 minus alpha, this z standard normal variable will fall between negative z sub alpha divided by 2 and z sub alpha divided by 2. So we have the probability that negative z sub alpha divided by 2 is less than z sub alpha divided by 2 is equal to 1 minus alpha. Now, substituting our equation here in for z, we can actually solve this for the difference of means of the population that we don't actually know. And when we're finished solving for the difference of the means, that can give us the confidence interval. So using the inequality that we found, we can compute a confidence interval for the difference in means of our population, the same way we did when we had a single sample.